In this lab, we are going to configure the BGP path attributes to influence the BGP path selection algorithm as we have configured in the previous lab. Now every router advertises its own loopback address with BGP. Let's say we want to get to router 5, so to AS 65005 from AS 65001, and we have multiple options to reach this AS. First, we could go directly to AS 65005 through router 3, or we could go through AS 65007, or we could use AS 65004. Now let's check the BGP table. What do we use by default? So on router 1, for example, show IP BGP, and we use the path through router 3, but we also have the option to use router 4, but router 3 is preferred because the length of this AS path string it's shorter, so we don't have to go through one additional AS. Now let's check router 2, show IP BGP. Router 2 also prefers the path through router 3 because of the same reason. The AS path is shorter. But let's say we want to use this link, so the link between router 1 and router 4, and we want that every other router within AS 65001 use this link and not this link. In this case, we could modify the local preference attributes on router 1. So what we are going to do here is we apply a route map on the inbound direction on this neighbor, so neighbor router 4, and we apply a filter on router 5's loopback address, and we set the local preference value higher than the default. So the default value is 100 and the higher value is preferred. And the local preference value will propagate through the whole autonomous system. So autonomous system 65001, and the other routers are going to apply this local preference value. Let's start by creating an access control list on router 1. IP access list extended, or we could create a standard or extended ACL. Doesn't really matter. We only need to apply a filter on the source IP address, and we name this use router 4, for example, and we need one permit statement. So permit IP host 5555, and the destination is any. And now we create a route map. So route dash map, we name this to router 4, for example, permit and the sequence number, and we need one match and one stat statement here. So if the advertised address is 5555/32, so match IP address and the name of the ACL, which was use underscore router 4. So for this prefix, we set the local preference, and we need something higher than 100. Let's use 101, for example. And we need one additional permit statement here with the route map, because there is an implicit deny at the end. So route map, the name was to underscore router 4 permit, and the sequence number, which should be higher than the previous. And that's all. We don't modify anything here. We just let the other prefixes enter the autonomous system. So now we need to apply this route map on the neighbor router 4. So in BGP configuration mode, router BGP AS number, neighbor, then 0.14.4, which is router 4, and route map. The name of the route map was to underscore router 4, and we apply this on the inbound direction. So we change the attributes of the routes we receive from router 4. And I reset the BGP peering to resend the update messages. So clear IP BGP. And let's verify what we have done on router 2, show IP BGP. And we use router 1 as the next hop, and AS 65004, which is router 4. On router 3, show IP BGP, we can see the same thing. So the local preference has been changed to 101, and it takes precedence over the AS path length if it is higher than the default, which is 100. So every IBGP router assigns this 100 by default in the rows where it is empty. So they are eBGP peers, but the local preference are still 100. In that case, we can prove that, show IP BGP 5555/32. So we have 3 routes available. The local preference is 100 in these cases and 101 in this case. So we choose the higher one, even if it has longer AS path length. And here is a packet capture of the update message which router 1 sent to router 2. The NLRI defines the prefix, so 5555/32, and we set the local preference value to 101. It says that it is a transitive and well-known attribute, but remember that it is only transitive within the AS. So AS 65001, and we don't send the local preference values to other eBGP peers. So it is only significant just within the autonomous system. Now, what if we want router 2 to take this upper path to reach router 5? So we want it to go towards AS 65007, but all the other routers within the autonomous system should be unaffected. So they keep using this path towards router 4 because the local preference is still in use. In this case, we can use the weight attribute on router 2. It is the most influential attribute, and it takes precedence over the local preference. So let's check router 2's BGP table. Now, as we have expected, router 2 is using router 1's loopback address to reach router 5, but it also gets the BGP advertisement from router 7, his eBGP peer, and router 1 is chosen because of the higher local preference. The weight attribute is 0 by default for every prefix, except for the prefixes which are locally originated. For example, 2222/32, which is the address router 2 has advertised using the network command. In that case, the next hop is 0000, and we assign the weight of 32,768, but we can modify the weight for any other prefix. So let's do that. In this case, we are going to create an AS path access list. So the magic rule is going to be a little different, but the effect will be the same. So IP AS path access list 1 permit, and here we need to specify a regular expression underscore 65,005 and $sign, which means any prefix which has been originated in AS 65005. This $sign indicates that AS 65005 is at the end of the AS path string. So the routes which we want to apply this filter on are originating in AS 65005. And we create a route map the same way as before. Let's name this to R7 permit sequence number 10, and as we have seen previously, we need a match and a set statement. So match AS path 1, and for any routes which are originated in AS 65005, we set the weight to, well, it's 0 by default, so we need anything higher than that. Let's say 10, for example. And one more permit statement to match anything else. So route map to R7 permit 20. So the other prefixes are not affected. This is needed because of the implicit deny at the end of the route map. And we need to apply this route map to neighbor router 7. So router BGP 65001 neighbor, then 0277, which is the IP address of router 7, and the route map, which was called 2_R7, and we apply this in the inbound direction. So the NLRIs we receive from router 7 are affected and should be changed according to the route map. And I want the changes to take effect immediately, so I reset the BGP session, clear IP BGP, and let's verify, show IP BGP, and indeed, the weight has been set for this prefix, and although the local preference has also been set, but the weight of this row has been changed according to the route map, and the higher weight is preferred. So we take this path towards router 7. And remember that the other routers in the AS are still using router 1 to reach router 5 because the weight attribute is not forwarded to anyone else. It is only locally significant on router 2.